Hello, this is Chuck Knox, and today is September 20th, 2020, and this PowerPoint is going to be over the combining LiDAR and modern seismic to explore for oil and producing horizons. And it's a new approach for the discovery of erosional remnants of the Cambrian Ordovician unconformity, and we're going to be looking out in Morrow County today. What LiDAR is? It is an extremely accurate laser survey. Surveys can be very large, such as the statewide surveys the USGS is now putting together, or very small, such as the scan of a human tooth. It is a powerful tool that can virtually strip away vegetation, man-made structures, any culture, roads, bridges to create a digital 3D image of the bare Earth surface. It is a technology that is becoming increasingly important to many industries. What LiDAR is not is a standalone remote sensing tool that can identify areas capable of producing oil and/or natural gas. LiDAR works by emitting a laser pulse from an emitter and measuring the time and intensity and angle that it comes back to a camera. This translates into distance from a sensor to an object, and you combine this with GPS, then you get an XYZ of a certain point on the Earth's surface. The result of this is a cloud of points, and each point has its own coordinate and height. And from this point cloud, we can detect digital elevation. We can create digital elevation models, we can slope angle models, flow accumulation models, aspect models. There's an abundant amount of data we could get out of the point cloud. Now I want to talk about modern 2D and 3D seismic. Wireless receivers are allowing for the optimal and economic design of a 2D and 3D shoot. We don't have to tailor make our arrays to the cost of the shoot. We can now use the optimal and economic design of the shoot. Wireless also allows for the survey on the fly, so we're reducing the need to survey locations prior to receiver placement. This cuts down the cost tremendously. Mobilization and demob cost are greatly reduced. There's not a huge amount of wire to move. And importantly, the modern 2D and 3D seismic produces high-quality data in shallow horizons at an affordable cost. Jack Racer of Racer Seismic Surveys, Selma, Indiana, is now using the modern wireless system. Here is a wireless node placed along the roadside. Notice no wires. Here is a Vibe and his crack team. In the early 1960s, an oil field was discovered in Morrow County, Ohio. These were Knox erosional remnants that protruded up through the Glenwood and into the Black River. In 1903, Knox erosional remnants were found in Red Key. Knox erosional remnants are found even as far south as Kentucky. They are spread over a wide area. The historic wells at Red Key were found in Jay County. In Jay County, there was numerous pays, and the Knox erosional remnants were in the fifth or last pay at 415 feet. The Department of Geology and Natural Resources report states the deeper pay wells were the most prolific producers in the start, some of them yielding from 200 to 450 barrels of oil per day. So here are some important benchmarks of remnant development in the upper Midwest. In 1903, oil is discovered in the deep pay at Red Key. In 1906, Standard Oil pipeline from the Mid-Continent oil fields to the Whiting, Indiana refinery is operational. This cut off purchasing of crude from the Lima, Indiana oil field. And by 1912, most of the Indiana and Ohio oil fields were in a state of abandonment, and this included the deep pay wells in the Red Key area. In 1959, oil is discovered in Knox erosional remnants of Morrow County, Ohio. In 1964, single-fold high-definition seismic was being used with great success locating the erosional remnants in Morrow County. 1967, a company, Moses and Stewart, drills 3 holes into the deep pay at Red Key, confirming that the original deep pay is in erosional remnants at the Knox unconformity. In the 1980s, computerized 2D seismic is used to expand the Morrow County oil field to the east. And in 2019, Miller out of Michigan uses the 3D seismic program to drill a successful oil well back at Red Key. So we've made a full circle back to the original discovery of the Knox erosional remnants in 1903 at Red Key. So in Morrow County, there are some observations that we can use and apply back to Indiana and actually expand the Morrow County oil field. Single-fold hand-plotted seismic had an 85 to 95% success rate in locating producing remnants. There is excellent correlation of surface features with subsurface structures, which plays right into the LIDAR hand. The bedrock surface maps and stream flow was used to locate potential subsurface targets. Most remnants were very small, only 10 to 40 acres, and only had 2 to 3 wells. But these very small targets had produced 80,000 barrels of oil over a 10 to 15 year lifetime. W. Schaefer was a geophysicist back in the early days of the Morrow County field, and he found that the single fold was far superior. This is what he said here. It was far superior to straight subsurface geologic mapping based on samples and geophysical logs. So the key to finding erosional remnants in the Morrow County was single-fold, high-definition seismic. And he found there were 5 repeatable observations on the seismogram. Decreased time, datum to the target. Decreased time, data to Trenton. Decreased Trenton to unconformity time interval. Unconformity signal breakup on target. And what we like to use out in Indiana is increased time, unconformity to the Eau Claire. Here is a sample of the single fold in Morrow County, Ohio. The circle, the yellow circle, is over a breakup of a Knox erosional remnant. Here is some modern 2D from the 1980s, and you can see where the yellow circle is, again, breakup over a Knox erosional remnant. Now I want to go to Jay County. Here in Jay County, here's a breakup over a remnant using modern 2D seismic. This is one of Racer Seismic Survey's 2D lines in Jay County. And the yellow circle clearly shows the breakup over a Knox erosional remnant. Here is a 3D over that same Knox erosional remnant. The yellow circle shows the erosional remnant. And here's a digital elevation model with marked remnants on the surface. Here's where the 3D chute was, and here's that remnant. As you can see, there's surface signatures that indicate the remnant. We will go into the DEM a little bit later. So now I want to go to using LIDAR data sets to track subsurface structures. In Morrow County, the area topographic maps contain an abundance of positive interpretive aids to the identification of subsurface structures in the glaciated and unglaciated areas of interest. And this is from W. Schaefer, who was the geophysicist back at the time in the early days. He supports this by 7 separate observations and offers this conclusion. The modern-day drainage patterns are often indicative of subsurface structures. So I'm going to say that again. The modern-day drainage patterns are often indicative of subsurface structures. We're finding this in Jay County, and we're finding it in Morrow County, Ohio. Mr. Schaefer later worked with Landsat data and often noted the correspondence of bedrock joints with the families of Landsat-derived lineations in Morrow County. Modern LIDAR digital scans of the Earth's surface can be used to track and interpret the modern-day drainage patterns. LIDAR can be used as a reconnaissance tool to locate possible remnants prior to a 2D seismic and leasing program. Here is our outline of Morrow County, Ohio. This is a LIDAR-derived digital elevation model of Morrow County, Ohio. With this map, I can put in all the dry holes. I can put in the producing oil wells or abandoned oil wells. Most of these are abandoned at this time. I can then draw my remnants in, and these are a combination of DEM and producing oil well. I can take out the dry holes and the oil wells, and then we have a first modern remnant map of Morrow County, Ohio. Let's take out the DEM, and you can see where the placement of all these are. Here is Jay County. We have Blackford County, Delaware County, and Randolph County. We're going to look in this central portion of Jay County. Here is the imagery of the area. As you can see, it's mostly farmland, abundant amount of trees out here, roads, houses, some culture. What I want to do now is put in the DEM so you can see the difference. Here's our color-coded, hill-shaded 3D image of the Earth's surface of that central portion of Jay County. You can see some stream flow, but it's still not very apparent. What we can do is, with the DEM, we can then do flow accumulation models, and these flow accumulation models is a digital image of stream flow. So let's put that in. Now we can start seeing what's going on. And with these flow accumulation models, then we could go in and use the tools developed by the photogeologist post World War II and put in where our highs should be. And here's where we're calling the remnants in Jay County. Now let's go back to Morrow County. This little area here is, I think it's called the Hidden Lake area, Congress Township and Franklin Township. Here's the imagery of the Hidden Lakes area. To the south and west is the campground. We have abundant trees. We can see some stream flow on the surface, roads. And let's take the imagery away and go to the LiDAR-derived digital elevation model. You can see the ancestral stream channels. There is some relief here that you really can't see on the imagery. Let's put in the flow accumulation model. And then what I like to see here is I like to see these areas like this where you get stream flow wrapping around an area. Let's put in the oil wells. Let's put in the erosional remnants that we're calling. Now, one area I like is this one right here. It's a single well, but look what it does to the stream flow around it. We get this bump here that comes out, this bump here that comes out and wraps right around it. A lot of times you'll get these things tucked right into these small little baskets like this, where you get stream flow that is diverged around an area and then comes back together. We've got these little wraps like this. So we're seeing a lot of signatures on the surface. So what I'd like to do next is, let's put in, take this out, take this out, take all this out. Then let's put in areas that I think where there's still some meat on the bone out here in the Hidden Lakes area. So the blue remnants now are areas where I think that there still could be remnants and potential oil production. As you can see out in Morrow County at the Hidden Lakes area, there is quite a bit of area to explore for. And these would be areas where I would have racer seismic surveys explore over the roads with a 2D program. So here's the Morrow County exploration model that I'd like to use. We use LiDAR-derived digital elevation models and bedrock surface DEMs along with local knowledge, and the local knowledge is extremely important, of the conditions of the historic field to locate areas favorable to remaining remnant development. We would shoot preliminary 2D reconnaissance programs over areas with potential. If preliminary 2D is successful in locating existing undeveloped remnants, we then expand the 2D to cross initial lines at points of interest. We lease areas with identified remnants, and we initiate a 3D program on leased acreage. Then drill identified undeveloped remnants. So we are using LiDAR and modern seismic to explore for Cambrian Ordovician erosional remnants in Morrow County, Ohio. This is a new approach to exploration. LiDAR, 2D, then 3D. Lower cost with better results. Thank you.